Welcome to Dialogues of Discovery, a platform where we bring you conversations with visionary thinkers and trailblazers who are shaping the future. If you are curious, passionate, or just figuring it all out, you are in the right place. Each episode brings you insights, experiences, and advice from the lives and minds of remarkable people, scientists, innovators, and creators, so you can get inspired, explore, and start carving your own path forward. Listen on to uncover more. Joining us today is Professor Soumyo Mukherji, current director of BITS Pilani, Hyderabad Campus, where he also serves as professor in the Department of Electrical and Electronics Engineering, while on leave from his long-standing faculty position in the Department of Biosciences and Bioengineering at the prestigious IIT Bombay. As a pioneer in making science practical and accessible, and with years of experience in the fields of medical instrumentation, biosensors, and nanotechnology, Professor Mukherji's work also spans optical fibers and diverse sensor technologies.
Professor Mukherji's research tackles a key challenge that impacts us all: how to detect diseases and environmental hazards quickly and affordably. His research group has developed low-cost sensor platforms, from paper-based electrochemical devices to nanoscale biosensors, capable of spotting everything from E. coli to heavy metals. Many of these ideas have moved beyond the lab into patents and real-world deployments, earning him honors like the Bira Gayati Award for Innovations and Deep Social Impact.
His work has also been recognized through his election to India's leading scientific academies, including the National Academy of Sciences and the National Academy of Engineering. With a BTech from IIT Kharagpur, an MS from Colorado State, and a PhD from UNC Chapel Hill, his journey reflects both technical depth and a commitment to meaningful application.
From mentoring students to creating technologies that address urgent medical and environmental needs, Professor Mukherji shows how engineering can directly improve lives. We're excited to learn from his experiences and perspectives in this episode of Dialogues of Discovery. Good evening, Professor Mukherji. It's really an honor to have you with us today. Thank you so much for making the time to speak to us, and we're really excited to speak to you and get an opportunity to learn from your insights. So, for the listeners who who aren't familiar with your area of expertise, could you share a brief explanation of your work?
You had an interview with Professor Ajay Ghatak earlier, right? Professor Ghatak is almost father figure of optics in India. I follow a little bit of his path, but much more in the applied sense. I don't understand theory as well as he does. What I do is use primarily optical fibers to convert them into sensors for a variety of applications like medical or environmental, or even for that matter, security. I also have other types of sensing mechanisms besides optical fiber sensors. I have an electrical chemical impedance based sensor or a nano heater based sensor and things like that. So essentially use fundamentals of the laws of physics and sometimes chemistry, biology, in order to measure and quantify the environment around us or around the sensor. That is what I do.
Okay, so you're talking about how you have these different kinds of fundamentals and you're basically finding ways to implement it, and you're building sensors, you're building different kinds of instruments that basically quantify and measure things.
Right.
So, following that thread, something that we were really interested to ask you is that why did you choose this? Like, why did you go into the field of medical instrumentation, biosensors, nanotechnology? What really inspired you to take this path?
Well, biomedical instrumentation, there's a very clear-cut story. My grandfather was a doctor, my father's a doctor, my sister's a doctor, my uncle's a doctor, and all sorts of doctors around. But I being the lazy person that I am, saw those big fat books and decided that I really don't want to read those big fat books. So I went into instrumentation as my undergraduate discipline. But you know what? This is what is called irony of fate. I ended up reading all those big fat books in my while doing research. So yeah, so that is where biomedical instrumentation comes from. And if you really look at the sensors point of view, I used to work on sudden cardiac death as to young people suddenly going to bed and not waking up. At that time, that definition of young people, mind you, was 45 to 55. Okay. Now that definition of young people has come down even to 30. And people are just, I mean, hale and hearty people suddenly passing away. That was my research area, but for research area, I cannot obviously do such research on human beings. So in the US, where I did my PhD, I did the research on pigs. The pig heart is almost the same as a human heart. You know, the human heart, your heart is roughly the size of your fist. Okay, the pig heart is roughly this size. So it makes a good model for the human heart. When I came back, really bred pigs were not cheap. They were very expensive. So I went to the local abattoir and asked them, can you give me some goat hearts? They thought I was practicing in some witchcraft or something like that. I showed them, no witchcraft. Come to my lab. I'll show you what I'm trying to do. One of those characters, they landed up in my lab. He was a local butcher. He landed up in my lab and saw that indeed I was doing some scientific experiments. And I started working on the goat hearts. But then soon after that, there was dictums passed by the government that you have to do this, that, and all sorts of things. And my research came to an abrupt halt. So at that time, someone came to me, why don't you develop sensors? I said, wow, yeah, that is something that I can do. So sensors, right? And now while doing sensors, the world of nanotechnology opened up in front of me, which makes the sensors much more powerful, much more sensitive, and much cheaper for that matter. So that is where the medical instrumentation into the cardiac research, into sensors, sort of maybe a little disparate, but there's an underlying thread of connection between them.
So thank you very much. It was really an interesting question, which we want to talk
But
about.
you will get the raw answer from me. Okay, I will not say that. Well, I wanted to do great for the human beings, yeah, oh, and all those things. I will not say anything like that. I'll give you down to earth practicalities. Okay, that is what you can expect from me.
Yes, sir.
Yeah.
It's really interesting to see how you, took a path different from your family, but still ended up in such a wonderful position, and have experimented in many, various kinds of situations. So, your experience has led you to getting almost like 25 patents. That's a lot of patents. Could you explain one of your, or talk about one of your favorites?
Number one, 25 patents is not so many patents. Okay. Number two is that, you see, I saw the question. The patents are based on discovery. And if I have really made okay, my students made the discovery, okay? They are the people who worked. They are the people who work their nights out, okay? While I'm having a sound sleep, they're working, huh? But they work. They work with my help, my supervision, my guidance. That's all. But anyway, the one that really excites me is the one with polyaniline, which is something that we discovered. Really, it was a discovery, interesting discovery. Plastics or polymers, they're typically insulating, right? Current does not pass through them, but around the 1970s, one Japanese scientist and one American scientist, they found out that under certain cases, certain of these polymers, they deliver, you can make them somewhat conducting. That means somewhat current does pass through it. Those are called conducting polymers. They started off with a polymer called polyacetylene. But later on, many other polymers were found, polyaniline, polythiophene, and lots of other polypyroles and all that. What we found was, and this has been somewhat explored in terms of if you have a pH change around the polyaniline layer, it changes the conductivity of the polyaniline layer, or the characteristics of the light passing through the polyaniline layer, it gets changed. That means different colors of light is absorbed in the polyaniline layer if the pH changes of the whole thing, if you dip in it. But what we found is, even if there are interactions, molecular interactions on the surface of polyaniline, in a very thin layer of polyaniline under the surface, the optical characteristics change. That means, let's say that I'm passing 540 nanometers wavelength light through the polyaniline, and I have a molecular interaction on the surface of the polyaniline that changes the absorption characteristics of that 540 nanometer light. This is something which no one had observed. We, on the basis of this discovery, we invented a series of sensors which use this property of nature, so to speak, and looked at, let's say, detection of antibiotic residues in water, or looked at ions like very, very small amounts, like femtomolars or picomolars of lead ions, or some other ions, cobalt, chromium, copper. All of these, they are on the basis of surface interactions of at the surface of this polyaniline. Now, will all ions interact with the surface of polyaniline? No. We have to functionalize the surface of polyaniline with something which specifically interacts with the ion or with the molecule of interest. Let's say that we have some molecule which interacts with lead. We make sure that the surface of the polyaniline is covered with that particular molecule. Now, when lead ions come in, they interact with that molecule and changes the property of the polyaniline. So this results in a variety of sensor possibilities. And that is something which was indeed exciting, because we have discovered a phenomenon and invented something out of it, and trying to develop the technology and the engineering around it so that it becomes end-to-end, it becomes a solution for us to measure various things. So right from discovery up to technology development, that whole path was covered in this sensor. So that is why this one is a particular favorite of mine.
Mm. I think what I find most interesting is the fact that you didn't just go up to discovering the phenomenon. You went up to the phenomenon and then you went to that sensor where you can actually do the part with the antibodies, the whole lead testing. And that is something that we really wanted to ask you about, because it's not very common. Like, generally, when you think of a researcher or a scientist, it's someone working with like a white lab coat in a lab, like very secluded from the world, is what I'm trying to say. Like, they're not really connected to, okay, these are the problems that we're facing right now. How is your research gonna change that? So that is something that I think I found really interesting about the work that you do. And I really wanted to ask you, what, like, why do you do this? Like, why do you go beyond the phenomenon and reach this whole sensor thing, the impact?
Otherwise, it's no fun. The fun is actually seeing it work. My seeing it in a test tube, I don't consider it to be work. Oh, I mean, working. It is definitely work, but it is not working. But it is fun to see it working and doing something. And by the way, I don't have a white lab coat. My students do. When I was a student, I had a white lab coat. Now I'm more or less in t-shirt and jeans sort of guy. So in the lab. But yeah, in certain photographs, I've been forced to wear a white lab coat, which I borrowed from some student. I recall, just to give a science, whatever aura to the story. Yeah, but no, I mean it's the students who do the work. They are, they're the primaries.
So is this kind of research like where it goes to a practical sense? Is that something that's common across India right now? Like what would it take to make it common?
It's a very good question. It's a very good question, and but you see, 10 years, 15 years back, if I said I work in technology, people will think that I write programs, and that used to really bug me. What? I mean, I do technology. I do real technology. Fortunately, now there's this word deep tech. I say I do deep tech. Deep tech means what? I do some physics, chemistry, biology, and all that, and put that on a layer of whatever software and use a software layer along with that and do quote unquote deep tech, right? So uh, this the whole the concept of uh, you know taking something from a very nascent stage in terms of someone's thoughts and test tubes, that is the part which really works out for me. And in terms of so I mean and that is what technology is about, isn't it? It is it starts off with science, then you do a technology, a technology meaning that it becomes useful, then you do engineering, when it becomes useful for the whole human race in some sort of way. And all of these just go a small path towards a market. Then you go into the market and try to sell it, and people might not find it useful. So they might not. So your company might go bankrupt, whatever. But there are. But these are challenges, and uh, if someone wants to rest on their journal papers and things like that, uh, and get a lot of awards for publishing like 500 journal papers, that's their idea of fun, right? My idea of fun is different. But the what is happening in the present world is we are changing the whole India as a country is changing from a more theoretical based sciences approach towards a more practical, hands-on, product-oriented science approach, where you have a product in mind, and that is good because you see. USA or Israel or Japan or Germany or UK, they did not lose focus of while they were doing these products, they did not lose focus on the fundamental science. So they balanced it out nicely. Because our resources were less, we did more of fundamental science and things like that, and theoretical science on a piece of paper or take a pen. What is the investment? A big fat ream of paper and some pen and pencils. Those are investments in science. Because of our lack of resources for the country, we had a difficulty in translating those things. But now the country is more mentally oriented, and there is some resources to make that actually happen. So I am seeing more and more students, entrepreneurs, and even quite senior people go into what is called deep tech and try to develop products which are useful for something. uh, Maybe measurement of water quality, maybe looking at blood pressure, whatever, looking at blood parameters, maybe developing the BrahMos missile, uh, or the Agni missile, or developing the Chandrayaan or something and some things. That is happening. That day I was having a discussion with some people who were all of them are PhDs. They were deep into quantum sciences. They're very deep into quantum sciences. They were trying to use this quantum science to detect the position of the instrument. That means a ship, let's say. The instrument is in a ship, so the ship, okay, in space, using quantum science to do that, right? So that is pretty exciting because now we do not depend on geographical features. How did, let's say, Magellan, who made a mess, Magellan did not make too much of a mess, but this Columbus character, he did a total mess of the things. He went by geographical features, landed up in some place and called it India. वो जहाँ पहुंच गया उसको इंडिया बोल दिया. Now that, we don't depend on that. So what we started depending on, the satellites which are hanging around the Earth in geosynchronous orbits, or this or that. But still there are errors, and their signals can be jammed. Let's imagine a system whose signals cannot be jammed because they depend on the whole Earth's magnetic field, or on the let's say positions of stars or something, or the direction from which some neutrinos are coming. I don't know, but deep into, I'm not into that area, but deep quantum science, very deep quantum science into detecting the position, their own position. Because if I know position, then I can sort of figure out, okay, if I want to bomb that place or do something, then I know the original position. If I don't know the original position, वो लाहौर को मारते जगह लाटूर को मारते है ना. So that is something which is, these are very deep science, extremely complicated and advanced science, which is now being put into practical use. It's happening.
Yes. So it's really interesting to see how you say that India earlier, we didn't have the resources, so we were more into theoretical based science, and now how we're actually progressing to actually implement it in our day to day lives and drive it into more product oriented research. Your area of expertise, that's biomedical, diagnostics. It's like a rapidly evolving field now. All of these more product oriented research and application based science. So, what in your opinion has say contributed to its growth, and what's your vision of this in the future?
What has contributed in a growth is what one might call a can of worms. You the human body is very, very complex. You think that you have solved one problem, you open the can, there are other words for it. Okay, you know that this you can do MRI. Okay, you can do MRI. Oh, acha hai. Where is the water in the body? It can figure out. But what is that water doing? So now we have to develop something else to figure out what that water is doing. So the interest in that in biomedical instrumentation and all that is developed because as days go by, we want to know more and more about our body so that we can restore normalcy in case of disease or other things. We can restore normalcy at the earliest and with the least possible intervention. Right. And the earlier we can detect, the better. And if the earlier we can detect, the better, then I cannot ask you every morning after you have your morning jog, go to the lab, give a sample of blood, take measurements, and then do whatever. That is not possible, right? So one has to develop things which will give early warning symptoms or early warning characteristics. And that is where medical instrumentation quite a bit is developing towards early warnings. And to make the early warnings, you cannot go into a machine. You have to have it on your body, like your earring. Okay, let's imagine that your earring has a nice little sensor in it, which will test out something, let's say heartbeat or pulse oxygen or something, right? You're not wearing anything particularly different, but or your spectacles. Okay, your spectacle is in your touch with the ear, with touch with the nose bridge and all of that. There can be some sensors embedded in there. The watch, the standard now, all these smart watches, right? It is very crucial, and that is where things are going. Wearable sensors, right? You while going jogging in the morning, you wear a particular type of t-shirt. Let's say you don't wear the regular t-shirt. You wear a particular type of t-shirt. Go jogging. That while jogging, it takes samples of the sweat and does measurement and all of that. When you come home, you hook up your t-shirt has a little port. You hook it up to your mobile phone, and your mobile phone okay, and gives you certain parameters. And if the parameters are off track, it will tell you. Parameters are off track. It will tell you that nah, you got to fix this parameter somehow. How do you fix your parameter? You go to the doctor, right? And the doctor gives you medicine. Now there are as way. I mean, you and I, okay, both are human beings, but the DNAs are different. DNAs are different, mean our proteins are different. Right? DNA to RNA to RNA, tRNA, and all those proteins and all. So our bodies will react differently to different medicines. So if that is the case, then we have to develop personalized medicine. तुम्हारा सर दर्द कर रहा है, if I get a sar dard, I take a paracetamol. Maybe in your sar dard, paracetamol does not work. It has to have some other medicine. Or in a more complex, I gave you a very loose example. Okay, if you go back into the early days of Ayurveda, okay, you look at Charak Samhita or any of those books, the Ayurveds will ask you 2 hours of questioning. बिठा के 2 घंटा question करें. And most of the questions it will seem to be irrelevant. क्या पूछ रहा है वो? Whether my grandfather had this problem or that problem, who cares whether I am having this problem or grandfather का लेके क्या कर रहे हैं? खींचातानी क्यों कर रहे हैं? But remember, all that is going into a decision-making process. And that decision-making process is what is NI. NI is natural intelligence. Now we are trying to take all of these disparate parameters. I mean, that is my hope for the future. We are going to take the disparate parameters and use AI in order to come up with a diagnosis and a possible treatment which is personalized. So I don't know whether that will ever happen. But with plenty and plenty and plenty of data, it might happen. Because the Ayurveds are, they depended on experience. How much experience that they'll hold your this thing raised by like 5 fingers and then they'll sit quietly. That Jinda hai kya mar gaya hai? You don't know whether he's sitting quietly and he say, hey, don't disturb. Chup. Okay, and they're sitting quietly like this, and then they're in ticking. They're feeling with their 4 fingers from the same line of the artery, they're feeling different things. Sometimes they're putting a little pressure over here, a little pressure over in with this other finger, a little pressure with this, and then they're trying to feel. And all of that has come from their experience, repeated learning. Okay, इसको इधर थोड़ा ज़्यादा pressure दिया, and that pressure does not transmit very well. That means उसका शायद ये problem है, and all sorts of things they made, right? So, medicine, data, lots of data, elimination of junk data to make real sense of what is wrong with the body. That is, I think, that is going to be the key in the medicine or the medical instrumentation of, I would say, the medium term, not even very long term, medium term future.
Okay, I think that's really interesting. You're talking about how right now it's very person based, like how much experience that particular person has. And it's not also right now when we're talking about at mass, how medicine and how that field really is, it's not very available or very personalized. But if we're going towards the future, we can make it that way, and that could be the future. Oh, I definitely agree with what you're saying about there's a lot like that can be built, that can be developed in this field. And I think there's more and more students who are also really interested in this kind of thing now. So, I mean, I just want to ask a question to kind of wrap everything up, bring it to a close. What is your advice to students who are keen to build careers in healthcare, environment, or in biomedical engineering in general? And if there was a message that you could share to the youth of today, like if there was one message that you could share, what would it be? Yeah.
4 words: study hard, have fun. Okay, now a little elaboration of that. Uh, Physics, chemistry, mathematics, biology. Study all of them hard. Have fun, not only in terms of your building up your mental and your physical strength, but also have fun learning. Because when learning becomes fun, then it stops becoming a chore. Okay. So study hard, have fun, have a lot of things in it. It's very easily said, 4 words. But there is a lot of things in it. Have fun is fun. You must have fun while studying also. You should be curious. Uh, Develop curiosity. A child from kindergarten or even younger, continuously, they're a pain. They'll continuously go and put their fingers in the whole plug point hole and they will explore this, they'll pull that thing down. They're curious about the world around them. And they keep asking you, why, what, you. Yeah. By the time you go to kindergarten, वो फिर भी चल रहा है. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we kill the curiosity. फन चला जाता है. Okay, so the fun has to be restored. The fun in learning has to be restored. And the moment that gets restored, the study hard will become study easy. Yeah.
Yeah. Thank you so much, Professor. That's about all the questions we've had. And we're very, very grateful for you giving your time out of your busy schedule and sharing your journey, your experiences with us today. And we were really, really, really inspired by whatever you've said. And we really hope to inspire those who will listen to us or watch this as much as we've been inspired by you today.
Yeah. My daughters are budding scientists. Let's see how that goes. Maybe you will too.
Yeah, thank you
Okay.
so much.
Thank you for joining us on this journey of ideas, inspiration, and innovation.
We hope this conversation has sparked some curiosity in you and reminded you that behind every great discovery is a human story of passion, purpose, and persistence.
Until next time, stay curious, stay inspired, and keep learning because the future is being built by the questions you ask today.
This is Dialogues of Discovery signing off.